Welcome back to Aurora Tech Channel. Today, I will be reviewing the highly anticipated Creality K1. While some people say it's just a clone of the BambuLab X1, I wouldn't say it's an exact replica. However, there is no doubt that Creality has used the BambuLab X1 and P1P as its blueprint, and has aimed to create something very similar at a more competitive price. The BambuLab X1 without the AMS is being sold for $1,199, while the P1P is priced at $599. The Creality K1 is also priced at $599, but it comes with many components that are exclusively found on the X1. Let's take a look at the features of this Creality K1. The machine is fully enclosed, and its appearance is pretty impressive. I'd say it's the most beautiful machine I've seen from Creality. The K1 is a Core XY kinematic machine, and its motion system uses linear rods. The X and Y axes are driven by NEMA 17 58mm high torque stepper motors, while the Z axis is supported by 3 lead screws. Additionally, the Creality K1 claims to have a top speed of 600 mm per second with a 20,000 mm per second squared acceleration, which is slightly faster than the BambuLab's 500 mm per second speed. It incorporates an accelerometer inside the printhead for input shaper calibration. The hot end uses a ceramic heater, which should provide more efficient heating compared to a regular heat cartridge. The maximum flow rate is 32 mm per second cubed, and the maximum nozzle temperature is 300 degrees Celsius. The K1 also features auto bed leveling and auto Z offset, which were achieved using 3 strain gauges placed underneath the bed. The bed level is adjusted using 3 lead screws, eliminating the need for a bed leveling knob underneath the bed. The nozzle is used to probe the bed and create a mesh by reading the data from the 3 strain gauges. In terms of cooling, the K1 utilizes a powerful part cooling fan along with an additional 18-watt auxiliary fan positioned at the side. The Creality K1 runs on Clipper firmware and supports cloud and local Wi-Fi printing. You can use their Slicer Creality Print to send prints directly to the printer over Wi-Fi. If you prefer to use a different slicer, you can upload G-code using the simplified Fluid Web interface or use a USB drive for offline printing. The motherboard of the K1 features a new design from Creality with an Ingenic X2000 chip. This chip has a dual 1.2 GHz processor and an additional 240 MHz processor. The MCU is a GD32-bit chip, and the printer uses an 8GB SanDisk eMMC for onboard storage. The printer is equipped with a 4.3-inch touchscreen featuring a new user interface. However, it does not come with a camera by default, and it's only an optional upgrade. I would like to thank Creality for sending me this machine to review, but before we get started, I would also like to thank our sponsor VOXELPLA PLA, who has provided us with filaments since 2022 and is the sponsor of today's video. VOXELPLA PLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA PLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 mm per second while maintaining a flow rate of up to 25 mm³ per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA PLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. For more information, please visit voxelpla.com. The machine comes in one piece, so there's no assembly required. The first time you turn on the machine, you're required to select the language, remove the screws that secure the machine during shipping, and ensure the inside of the machine is clear without any leftover protective materials. Then, we can connect it to any 2.4 GHz Wi-Fi network and select the time zone. In my opinion, it would be better to show the city names in alphabetical order instead of the UTC time zones. After that, if you want, you can bind this machine to your Creality Cloud account. If not, you can just skip this, but you basically just need to scan the QR code and the app will get it done automatically. Up next is a self-test. It will test all the fans, heat up the nozzle and bed, do input shaper calibration, and do auto bed leveling. When it's calibrating the input shaper, you will hear the machine sound and vibrate like this. Then, it will clean the nozzle at the back of the print surface, try to level the 4 corners, and after that, it will do a 25-point auto bed leveling. The Z offset is automatically set, so we can just load some filament and start our first print. I will start by using Creality's Hyper PLA, which is the high-flow PLA that's supposed to work well with the K1. Set the loading temperature and select Extrude. Okay, filament is coming out, so we can start our first print. Let's try the 16-minute Benchy G-code that comes with this machine. As some of you may be interested in hearing the sound of the machine, I will not play background music for this print. As it's now printing quite fast, I will test how loud this machine is. When the door and top cover are open and the sound meter is a few inches away, the sound level is in the low 70s in decibels. When I step 2 feet away, when the door and cover are still open, the sound level ranges from the mid to high 60s. When the machine is fully enclosed, the noise is in the high 50s. Okay, the print finished in 16 minutes. It looks pretty good, and I can't see a huge decrease in quality compared to a Benchy printed at a normal speed. As this hyper white PLA hides the layers pretty well, I will try to move the light source to a different position. When zooming in this close, the layers and surface still look clean. Everything seems to be working fine, so let's move on to some more test prints. There is a 600 millimeters per second file, so I will start this print and see how fast this print looks. Let's test the sound level one more time, as this machine is now running at its top speed. When the door and cover are open, the sound level is around 70 decibels. When it's fully enclosed, it's in the low 60s, which is 2 to 3 decibels higher than when it was printing the Benchy. the print finally finished in 9 minutes. To print something at this size in such a short time is extremely fast, as even though it is a vase mode print, it almost took up the entire x-axis of the print bed. The print quality is still nice. I'm not sure if this is just because the Hyper PLA hides layers well, so I will try to reprint this 600mm per second model using Lavender Purple VOXEL PLA Pro, which claims to be able to print at 500mm per second. It seems that VOXEL PLA Pro can print even at the 600mm per second speed without issues. It still looks pretty good compared to the one printed with Creality Hyper PLA. Next, I will print the new model from Prusa, the Robo Alpaca. I've printed this model on the Prusa MK4, MK3S Plus, and the BambuLab P1P. So now, let's try it on the K1 using the same Tronxy tricolor silk PLA filament and compare the results. The print took 4 hours and 40 minutes to finish, and overall, the print quality is still good. I've put this set of pictures comparing the 4 prints on my web server for you to download if you want to do a detailed comparison of the print quality of these 4 machines. In my opinion, the MK4, which took 7 hours and 50 minutes to finish the print, did look the best. Then, I will print a set of drawer towers. These honeycomb pattern drawer towers require an excessive amount of retraction, so it's a good test for the extruder. The drawer tower took 4 hours and 15 minutes to finish. It printed very nicely. All the honeycomb patterns were printed without issues. It seems the K1 extruder can handle the retraction pretty well. After that, I will print 4 drawers. Generally, printing 1 drawer on a normal printer will take over 2 hours, but using this K1 to print 4 of them only took 2 hours and 13 minutes, which is 4 times faster. The first layer looks okay, even though it nearly uses the whole print bed. However, I didn't apply enough glue on the bed and the front of the bed has almost no glue, so the corner of the drawers warped a little. The drawer at the front right also has a missing line on the surface, but the other 3 drawers are fine. I'm not sure what caused that, but besides that, the entire set of drawers is functional. I will reprint the same G-code with 4 screen VOXEL PLA Pro and see if the same line will show up at the same or a different spot. This time, the print finished without issues. The drawers mixed with different colors still look pretty nice. After that, I will print a tank with the 4 screen VOXEL PLA Pro. I've rotated the tank 60 degrees to avoid adding too much support. The result is okay, and the cannon of the tank is printed okay as well without support, and I can't see other major issues with the print. Next, I will print a model of the Hulk. This thing is big, and it nearly used up the entire print volume. The Z height of this model is 220mm, and with an Ender 3S1, it would take up to 23.5 hours to finish, but with this K1, it just took around 5.5 hours. The final result looks alright. The print finished with no major problems, except that the part where I manually added support wasn't printed too well, as the manual support tool is better than Cura, but not as handy as Prusa or the bamboo slicer. Then, I will print the Statue of Liberty using an automatic tree support. This tree support looks very easy to remove, and it really is. The model looks okay except for the book and torch, as the automatic support generating feature didn't support these two areas well enough. Up next, I will use the fire orange voxel PLA to print a model of a Suzuki Jimny, but it looks the same as a Jeep to me. The print only took 2 hours and 50 minutes, whereas a normal printer would take 9 hours. After that, I will print a disc for a jar. This is a model we designed for a local business that needs to do small batch production of this disc, and it has to be an airtight fit with their container. Printing one in the center of the bed is something most printers can do without issues, but when printing 9 of them on the same print surface, it may not be the same. If the bed leveling isn't working well, some of them may not fit. They look fine, so I will test each of them. I want the disc to fit with the jar, so when I shake it, it shouldn't fall, but it should still be able to be removed without too much effort. In the end, 8 out of the 9 discs fit perfectly, and only 1 is slightly loose, so I consider the bed leveling sensor to work pretty well. Next, I will print this dragon model using the Fire Engine Red Voxel PLA Pro. I previously printed this dragon with regular support. This time, I will try the tree support automatically generated by Creality Print. The print finished in 7 hours. The tree support can also be easily removed, so this time I don't have any complaints about this model. After making quite a lot of PLA test prints, let's try some other materials, starting with Eryone white PETG. I will just use the default PETG profile and see how it prints. Even though the print speed for all materials is set to 200 to 300 mm per second, the volumetric speed is actually limited in the material profiles. For example, Hyper PLA is set to 23 mm³ per second, but PETG is set to 9 mm³ per second. So even though the print speed is set to 200 to 300 mm per second, it will actually print slower to match with the volumetric speed. As you can see, there is some under-extrusion, which means the filament is not being melted quickly enough to keep up with the speed. But I'll just let it finish and see if the wall can keep up with the speed. The wall looks perfect. The bottom is alright and not too bad, but the inside of the trash can shows under extrusion at the bottom. Next, I will try some ABS. As the fan at the rear of the machine doesn't come with a filter, I will use the VOR smoke purifier to filter the air. The flexible hose can just stay at the back of the machine. The print finished in 3 hours and 23 minutes, which is way faster than the 8 to 9 hour print time of a normal printer. As the machine is fully enclosed, this ABS print is perfect with no layer separation or warping at all. The pattern is also printed nicely with almost no stringing. Up next, I will try some TPU to print a card wallet. It was printing well at first, but after a while the nozzle clogged. I think the reason is my garage is too hot in the summer. As the room temperature is over 34 degrees Celsius and the inside of the printer is higher than that, this will make flexible filament more likely to clog. I restarted the print at night where the room temperature drops to around 30 degrees, and this time the card wallet printed without issues. The extrusion is good, and I can't see any issues with this print. I will print another TPU ball. I made a cylinder support at the bottom and just printed it without generating support from the slicer. It finished quite well, and the ball is also bouncy. Finally, as the maximum nozzle temperature of this machine is 300 degrees Celsius, but it doesn't come with a hardened steel nozzle, I can't print nylon carbon fiber or glass fiber with this nozzle, but I can print some polycarbonate. I will use some Polymaker Tough PC to print an X-carriage plate for the Ender 5 or the Silva SV05 to install the Creality Sprite extruder. The print finished in 46 minutes and the result looks alright. The polycarbonate sticks perfectly and the part looks good to me. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. It's fast. It can print at the same speed as the BambuLab machines and still retain high print quality. Its 600 mm per second speed and 20K acceleration are a little faster than BambuLab machines, and one of the test prints that came with this machine really demonstrates the top speed of the printer. But in terms of printing regular models, using the default PLA profile that prints at around 200 to 300 mm per second will have good print quality. 2. The top of the machine is one-piece aluminum. The entire frame is more sturdy than other frames made of aluminum extrusions and tightened using screws on other printers. 3. The auto leveling and auto Z offset work well, so you don't need to manually adjust the distance between the nozzle and the bed, and the machine just calibrates everything itself, making it a machine that prints right out of the box. 4. It prints well with almost any material. I tested PLA, PLA Pro, PETG, ABS, TPU, and polycarbonate. It handled most of these materials well even at high speeds, except for PETG and TPU, which required a slower print speed, but this is reasonable as you just can't print every material at a super high speed. 5. You don't need to print using the Creality Cloud anymore, and you can just send the print job using Creality Print, which is their own slicer, over the network. Creality Print has improved a lot. The user interface is also much cleaner than the previous versions, so it's very much a usable slicer. If you prefer to use your own slicer, you can still upload the file using the web interface, but I will talk more about this in the cons section. 6. This fully enclosed machine prints tough-to-print materials like ABS and polycarbonate extremely well. A well-made enclosure alone will cost you $300, but this machine comes with a glass door, pixel glass side panels, and an injection molded removable top that looks like it's made of polycarbonate, so these parts are very well made. Now for the cons. There were no major issues during my testing. It's highly impressive that Creality can make a machine like this with so many features at such a low price of just $599, but I would still like to offer some suggestions. 1. Creality Print has improved a lot compared to its previous versions, but one of the most commonly asked questions I saw in the community is how to get rid of it and use other slicers. In fact, the Creality Print is not that bad and is fully functional, but there are some minor bugs, issues with slicing speed, and other features like support painting that don't work that well compared to the Prusa or Bambu slicer. It's completely fine for Creality to design their own slicer to provide a full 3D printing solution at no extra cost, but it's important to give customers an option to use something other than Creality Print. For now, you can still use other slicers to slice a G-code file and upload it using the simplified Fluid web interface or use a USB drive to print offline. It will be better to keep the Moonraker plugin functional so users can just send print jobs directly from Cura or the Prusa slicer. 2. The extruder gear is made of plastic, and so far it works fine without any issues. However, only time can tell if it will stay reliable. Personally, I still prefer extruders with metal gears. 3. The filament sensor is at the back, requiring you to twist and bend the filament every time you feed it in. This isn't a huge deal, but just integrating a tiny filament sensor in the print head would be much easier for filament feeding. The reverse Bowden setup also creates some extra friction for filament feeding, but it seems the nozzle clogging issue with the TPU is mainly caused by the high room temperature. I don't see any issues when printing with other materials. 4. If you need to print multiple colors or use water-soluble filament or breakaway filament to print support, the K1 doesn't have any options to upgrade to a multiple filament system. 5. As for the other accessories, the print surface is a sticker steel sheet similar to the BambuLab X1 Cool Plate. For small prints like a 3D Benchy, you may not need to apply glue and it still prints well. But for larger prints, you still need to apply glue. Creality could consider adding more print surface options like the PEI and PC print surfaces. Additionally, the fan at the back of the machine doesn't come with any filters. It would be better to have 3D models for a filter box or a ducting adapter to exhaust the air outside while printing ABS or other materials that require good ventilation. But for this price, I won't request that much, and I just want to see some free STL files available for download and more optional accessories for purchase in the future. Finally, the maximum nozzle temperature of this machine is 300 degrees Celsius, so it would be better for the printer to come with at least one hardened steel nozzle to print abrasive filament like different carbon fiber or glass fiber combinations. In conclusion, the Creality K1 is the most advanced Creality machine I've ever tested. It's beautiful, well-made, prints fast, and prints well. To get all these features for just $599 gives this printer an amazing value. Creality's strategy to make something in between the BambuLab P1P and the X1, but at the price of the P1P, is successful, which can be proved by looking at how BambuLab reduced the price of the P1P from $699 to $599 to match with Creality. I think customers are happy to see manufacturers competing with each other and making better machines at lower prices. Anyways, Creality really did a great job on this machine, so I will award this printer the title of the best value, fully enclosed high-speed 3D printer on my website auroratechchannel.com. This will be the 6th printer I would recommend out of all the 3D printers I've ever tested. If you're interested in the Creality K1, I put the link under the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.